Okay. In this lecture, we will discuss about K-map. K-map is an abbreviation for Karnaugh map. K-map is used for logic minimization. It is a simplification technique for Boolean expression. Now there is a question, we have already seen Boolean algebra, then what is the need of K-map? When we are solving the questions using Boolean algebra, then there is a possibility of different answer for the same equation, as the person who is simplifying it may use different rules of Boolean algebra to solve the same problem. K-map avoids this confusion. Also, K-map is ideal for combinational circuit design. K-map gives systematic simplification of Boolean expression with less number of calculation. It is always good to use K-map for combinational circuit design. So what is K-map? Basically, K-map is a pictorial or a graphical representation of a Boolean expression. It removes unwanted variables and it also gives the better answer with less number of ambiguities. I have taken a truth table on the left side representing two inputs A and B and one output F. When we have two inputs, then the four combination of inputs are possible. Just remember the formula 2 raised to n, where n represents the input values. F is a output, so right hand side there is a K-map of size 2 by 2. Also we have inserted the values of output ABCD into a respective cell. Again here I have taken example of two variable K-map. How it is just an indication that how we create. It's not a hard and fast rule that you have to take A towards the x-axis and B towards the y-axis. Both combinations are possible. Just remember the number of cells must be equal to 2 raised to n, and where n indicates the input. Also K-map use the gray code, though it looks like matrix, but no, while inserting the value gray codes are used. It is very much important to understand the relation between truth table and K-map before we start the higher level of K-map creations. So the dotted arrows are representing the input values in a corresponding cell with respect to the input and output values y. Now here I have encircled the two ones. Why? Because whenever we are creating the K-map, we have to create the groups. This group may be of 2, 4, 8. This is the possible and allowed. This is the possible grouping in K-map. Always remember, whenever we are doing the group, we have to select either consecutive 1 or consecutive zeros. Here I have selected consecutive 1 because I am proceeding for the SOP. SOP is sum of product form. If I want to go for product of sum, then I have to select the grouping of zeros. This is the basic difference between sum of product and product of sum, which we have already seen in Boolean algebra and Boolean algebra methods of problem reduction or logic minimization. This is an example of 3-input K-map, how it looks like. Just remember the values which are inserted in the K-map, they are not the serial one, they are the gray codes. Gray code are the one in which two consecutive numbers have 1 bit difference. I am talking about the binary. So this is a K-map for 3-input, where C is taken towards the vertical columns and AB taken towards the horizontal columns. I have taken an example. There will be 8 combinations and it is very simple to create this table. Just remember, you have to write the binary numbers from 0 to 7, which is nothing but total 8 combinations of 3 input, and certain F is nothing but the output given. And now we have to find out the Boolean expression for a given truth table. So as 3 inputs are given, so we have to create 3-input K-map. Also we have to map the values. So we will consider the first case where 0 0 0 is giving 1, output is 1. Similarly for 0 0 1, the output is 0. 0 1 0, output is 1, and so on. So similarly we have to fill all the values into the K-map, and then we have to encircle, or we have to create the group of corresponding ones. The corresponding one, after doing the grouping, we have to identify the expression only for the groups, and we have to ignore the zeros present in the given K-map. So for the first group, I am considering here cell number 0 and 2. Always remember, cell number 0 and 2, try to find out the common values. So if you look at C is common in both the cells, as this is the only representative of your horizontal cells. Similarly, in vertical columns or in vertical cells, A bar B, that is 0 0 and 0 1. So A is a constant one because both the cells A value of A is 0, and for B the value is 0 and 1, so it is getting changed. So we will consider only 0 0, that is A. So the equation for 0 and 2 will be A bar C bar, because it's 0, so 0 is indicated as the negation of the value. Similarly, for cell number 2 and 3, the common values are A bar B, that is 0 and 1. After finding out the terms, we will do the OR operation, and the final expression is arrived. So this is really, it's very simple to identify the Boolean expression without doing much calculation, or without applying big or without remembering the Boolean algebra rules. That's why K-map are very useful and utilized in many combinational circuit designing. Thank you.